Away we go. Classify x to the fourth minus 2x plus 3 by degree and number of terms. This is a quartic. So it goes constant, linear, quadratic, cubic, quartic, quintic. I don't think we have an x to the 5 on the test, quite frankly. Number of terms. What happens when we have 3 terms? It is a trinomial, like a tricycle. What is it after 3? Polynomial, all right? Don't start making up words. We only have monomial, binomial, and trinomial. That's it. After that, it's all polynomials. As a matter of fact, they're all polynomials, but then you can get more specific. So this is a trinomial. Find f of r plus 2. Now what you do on this one is you put r plus 2 in for this x. We don't do this one very often. Put r plus 2 in for that x. Don't forget the other x. You got to put them in for all of the x's, not just the first one. So we have 3 times r plus 2 squared plus r plus 2 minus 4. So there it is set up. So where there were x's, we now have r plus 2's, and now we just have some algebra to do. We need to FOIL r plus 2. That's r squared plus 4r plus 4 plus r plus 2 minus 4. So there's the FOIL. Distribute the 3. 3r squared plus 12r plus 12. Yep, plus r plus 2 minus 4. Now collect all the like terms. Well, we have just the 3r squared. 24 plus 1, that's 25, minus 2. There we go. That's the answer I get. Hopefully I didn't make any little mistakes. I think I added it right. Questions on that one? Replace all the x's with r plus 2. On this one, there's a couple ways to do this. Here's how I would do it. I would do r to the 24, s to the 15, r to the 9th, s to the 33. That's what I would do to start this one out. Power to power, you multiply. If that was negative, I would consider the negatives. Now, if there's 24 on top and 9 on the bottom, there's going to be 15 left on the top. 9 of those will cancel. And then we'll have s to the 16th in the denominator. There's 16 more in the denominator. You got a question?
No.
You sure? Ask me later if you still have one, all right?
Okay.
Solve this right here. It should say equal to 0 right there if you want to tack that on. Not a huge deal, but we need an equation to solve. Now this is the sum of 2 cubes. I'm going to erase this for the test. So make sure you have these 2 patterns memorized. I will not leave that up there for the test. The A is 2x. The B happens to be 1. 1 to the 3rd is 1. There's your A and your B. Well, then you follow the pattern. A plus B. Same, and then I used A. It's supposed to be x's. There we go. The A is 2x plus 1. So once you find the A and the B, you follow the recipe. And we're doing the sum of 2 cubes, A plus B, 2x plus 1. And then it says A squared. That's 4x squared. Notice I don't have 2x squared. A common mistake for this is that you only square the x and you forget to square the number. I see that all the time. Don't forget to square the number. Minus a times b. Well, that's 2x. Now, if that would be a 5 to the 3rd, that'd be 10x, because you're going to multiply the 2 together. And then finally, plus b squared. So it's the same sign. Then it's the opposite sign. And then it's always plus. It's so. Same, opposite, always plus. Same, opposite, always plus. Well, we have 2x plus 1 is equal to 0. 2x equals negative 1. Negative 1/2. There's your first answer. That's the real answer. And on the sum and difference of 2 cubes, you have 1 real and you have 2 imaginary. It's always that way. 1 real, 2 imaginary. So x is equal to 2 plus or minus square root. B squared minus 4ac all over 2 times a. You must know the quadratic formula, and hopefully you've been using it enough that you just know it by now. I would hope anyway. 2 plus or minus 4 minus 16, that's negative 12. Over 8. 4 minus 16, negative 12, yeah. Negative 12, square root of negative 12, that's going to be 2, plus or minus, it's going to be 2i square root of 3. 12 is 4 times 3. Square root of 4 is 2, there's the 2 out front. All over 8, and then we have to do a little bit more. 1 plus or minus I square root of 3 over 4. Now, what I had some people doing was when you take, I had this. What was it, like 2i square root of 3 over 2? Let's say it was that, and it's not. Here's what I saw earlier on some other assignments. You were going, well, 2 divided by 2, and I just had this, plus or minus I square root of 3. Like, you canceled that out like if it goes away. Now remember, we're dividing everybody by 2. That's a 1. 1 plus or minus I square root of 3. It doesn't go away. 2 divided by 2 is not 0. And that only happened a few times. Any questions on the first slide here? Let's move on then. We're going to keep solving by factoring. This is 3 terms. So we have 0 is equal to x squared minus 9 x squared plus 2. Factors of negative 18, they add to negative 7. There we go. I can keep factoring this. X plus 3, x minus 3, but there's no sum of squares. There's no sum. There's difference of 2 squares, but not a sum of 2 squares. As a matter of fact, the solution to the sum is going to be imaginary. So now we got to find out what makes each of these 0. Negative 3, 3. X squared is equal to negative 2, right? We set that equal to 0. Minus the 2 over. Square root. So x equals, what would we never ever forget ever? Plus or minus, right? Hopefully you've done that so much now that it's just automatic. It's plus or minus, and we have I square root of 2 because we're square rooting a negative number, so that's imaginary. Any questions on that one? Don't forget the plus or minus. How many terms do we see? 4, so what are we going to use? Grouping. Grouping when there's 4 terms. 0 is equal to, factor out an x squared. Factor out a 5. Both of those parentheses must be the same if you can factor by grouping. If they are different in any way, you have to use the process where you look for zeros and the synthetic division and all that. So we set this one up so that those parentheses are the same thing. X squared plus 5 comes back together. The x minus 6 comes back together. Not the form squared, that's not the way it works. So x squared is negative 5, and we would never forget plus or minus. We have plus or minus I squared of 5, because we're squaring in negative again. Another example, we're squaring in negative. And then x equals 6. Questions on that one? 4 terms, factor by grouping. That's an automatic. 4 terms if it's in the grouping section. Or not grouping section, if it's in the factoring section is what I meant to say. Use synthetic division to find f of negative 2. Well, I know what it is. It's negative 8 plus 4 is negative 4. I'll bet it's negative 3. That's what I'm guessing. I'm guessing it's negative 3. Because if you plug negative 2 in, let's see, that's negative 8 plus 4 is negative 3. But if you plug this in synthetically, the remainder should be negative 3, should be the same. 1, 0, negative 2, 1. Would you have forgotten the 0? Don't think so? I hope not. We're going to find out tomorrow if you're going to forget the 0 or not. Got to have all the powers, remember. I hope nobody forgets. I want you to have great grades. That's it makes me look good. It's all about me. I'm just kidding. It's not. 4, 2, negative 4. I'll be darned. So here's what we write. We say f of negative 2 is equal to negative 3. It's the remainder that we're looking for. It's called the remainder theorem. It says if you plug the value in, you'll get the same value as the remainder. Yeah.
So on the test tomorrow, if we don't write f of negative 2 equals negative 3, would it be wrong?
I wouldn't give you full credit. You gotta indicate to me somehow you know what the answer is. What I'm looking for. Do you hear the question? You don't write that down, am I gonna get it wrong? Just won't give you full credit. You got to indicate to me that you know what the answer is. And this is how you indicate it right there. Make a note of that. List the possible rational roots of that. Now, on the test, if it says this one, don't solve it. It's not asking you to solve it. It's just saying what are the possible rational roots. So we have 1, 2, 3, 4, lots of them, 6, 12. I hate seeing 12 because there's lots of factors of 12. Now we got to put those over 1 and we got to put those over 3, and there should be some repeats. All right, so the possible rational roots or possible rational zeros. All of those over 1. All of these over 1. You just get the whole list. Now, all of these over 3. 1/3 is a new one. So P's over the Q's. 2/3 is a new one. 3 over 3 is not a new one. That's 1. I already have 1. It's right there. 4/3, new one. 6/3 is 2. Got that. 12/3 is 4. Got that. You don't have. Oh, I thought you were messing with your phone. I was gonna, because you remember easy access. Oh, that would have been a bad day. Go ahead.
Do you want us to do the plus or minus, or like?
Want you to what?
Do you want us to put like the plus or minus, because that can take quite a bit of time, or do you not care if it's
Do
like
what I do.
Okay.
Do what I do is a good rule to follow. Divide using long division. I thought for sure you got that thing. All right, we got to write everything. That's why we like synthetic division, because we don't have to write all this. But it's long division. We have to do long division in calculus in order to do what's called integration. And then if you have what's called partial fractions, you have to do long division. So long division isn't really useful in algebra 2. I'm going to tell you that right away. But when you get to calculus, if you're ever to get that far, whether it's here in high school or in college, you'll have to do this long division stuff. It comes in real handy. 3x to the third. We only look at the leading terms. We make the leading terms the same. Whatever happens after that happens. 3x to the fourth plus 12x to the third. Negative 5x to the third. And dealing with all these pluses and minuses, that's probably what makes this a little difficult. Keeping track of everything. You just have to be very careful. All right, we bring down the next one. And we have minus 5x squared. So minus 5x to the third minus 20x squared. Subtract. Now, I don't mess with the signs, and then when I multiply, I just add that minus. That's how I do this. Negative 24 minus negative 20, that's negative 4x squared. Right? Yep, negative 4. So we have minus 4x. Minus 4x squared minus 16x. We subtract again. Negative 12 minus negative 16 is 4. Plus 4, so we finally end it with 4. We just make, all we care about is the first one. Just match up the first one. Whatever happens after that, we deal with it. 4x plus 16, we minus. I get negative 12. So we have 3x to the third. This is kind of a long one. Plus 4. And then we have minus 12 over the original, x plus 4, what we're dividing by. That's kind of like the mixed numbers. Except we have a bunch of variables in here now. Questions on long division. Once you get the hang of long division, not that bad. You just got to be careful with all those signs. Now this is an x to the third. We just need to find 1, and we got to an x squared, and they give you 1. Awesome. We're going to plug 2 into the box. Notice this, and I had this mistake. Let me see your eyes. I know you want to do this really bad, but let me see your eyes. When you are given the factor, you plug in what makes that 0. If we go back to the, where was that, where we were talking about, right here. When it says find f of negative 2, you plug in negative 2. You plug in what is given to you. And I had just one of you, wanted to do the opposite, so I thought it was worth mentioning. You plug -2 into this, but when they give you the factor, you actually plug in a +2 for that one. You guys see the difference? Any questions on the difference between those two? All right, let's finish it out then. Three, 6, 1, 2, -2, -4. Now we were told that's a factor, so the remainder better be 0. And it is. 3x squared plus x minus 2. Does this factor? I think it does. 3x and x. I need a +1. So how about +1 here and -2 there? That'd be a 3x minus 2x is a +1. So x equals 2/3. X equals -1. And x equals 2. There are the 3 zeros. Questions on that? All right, last one. We'll try to get the assignment done before we leave. That would be nice. Find all the zeros. 1, 2, 4, 5, that's the 20, 10, and 20. Those are your possibilities. Those are your possible rational roots. So we try 1. One, 0, 6, 20. On the test, if this is the last problem on your test and you leave the 0 out, you will not find one that works. You will sit there for the next 20 minutes and wonder why you're not finding any that work. And it's very frustrating. Very frustrating. You'll come up to me, very frustrated, and you go, I can't find any that work. And all I'll say is, you left out the 0. And you're like, oh, that's all I did? I left out the 0? Happens all the time. It is frustrating. 1, 1, 1, 1, 7, 7, not 0. I don't know if I did this one earlier. Anybody find one that works yet, by chance? -2 works, thank you. We'll speed up the process. So I try 1, try -1, try 2. You guys told me -2 is the one that works. One, -2, -2. 4, looks like 10, -20, and 0. Factors of 10 that add to 2, 5 and 3. X minus 5, oh no, wait, no. 5 and 3 is 15. Quadratic formula, right? Shoot. All right, here we go, we got it. 2 plus or minus square root of 4 minus 4 times 1 times 10 all over 2. B squared 4, I got the 4, I got the A, I got the C. 2 plus or minus the square root of 4 minus 40, -36. Over 2, so x equals 2 plus or minus 6i over 2. I can divide all those by 2, so it's 1 plus or minus 3i, and x equals -2. Don't leave this up here in synthetic division and go, Mr. Smith gets it. He knows that's a 0. You're right, I do. I want you to tell me you know it's a solution by listing this right here. So this is what I would want to see, again, to receive full credit. And once again, when you divide this by 2, it doesn't go to 0. So you divide by 2 is 1, make sure you have the 1. Don't make it a 0. Thanks for your attention today. I know that was a little long, but